Okay, so what we're looking at here is an activity for transformation of data, and that's when we do is when we get this, an XY plot where it's nonlinear, and when we do the transformation, we want to result in the best linear model. And we look at two things when we do that. When we transform the data, we look at the residual plot, check if it's linear, and if it's linear, we then check out the coefficient of determination, and if there's multiple linear values, we go for the one with the highest R squared value. Okay, so we decide which one is our independent variable and our dependent. In this case, our independent, which is also known as explanatory variable, is going to be temp, so temperature. And our response variable, which is our dependent, is going to be the student's, let's call it student jumper, stud jumper. Okay, and then we plot that y against x, see if it's linear or nonlinear, i.e. residuals. Look at residuals, okay, and find the R squared value. So let's have a look. So if I've got y against x, and I've actually already pre-done this, instructions can be seen here to get your residuals up. That's how you get the residuals. And if you want to get the R squared value up, you can get the R squared value up using these instructions here. Okay, so let's go back to this, and we can see from the residual here that we've got a pattern. I've got a pattern, that means it's nonlinear. Okay, so we're going to see it's there's a pattern in residual. Okay, and the R squared was 0.80. So what we can say the relationship between x and y in this case is non-linear. Okay, so when we look at this, we want to compare the shape of the plot against the shapes in the circle of transformations, and let's have a look at our shape of our data. It's in this direction, so it's going to be in this part of your circle of transformations. And then for each of those transformations, we look at the scatter plot, get a visual description, we get the R squared. What's a visual description of the residual? Does it have patterns, no patterns? And we put the regression equation in. Okay, so let's have a look at this. So as you can see, I've already done that data. All you need to do here is you go y divided by, and I've called it y just so we don't have any confusions later on. So basically, and then it fills down. It fills out down all the data you've got there. Okay, so all I need to do here is change one of my variables. So let's look at the first one I've got. I've got x versus log y. Okay, so I'm going to have x here. I'm going to change that to log y. All right, and we can see that in this case, we can see here that with the residual, I've got no pattern. It's basically, I mean, from what we can see here, it's scattered. But what we can do is if we want to zoom in, we go that menu, window zoom, zoom data, and it's going up and down. It sort of almost looks like a pattern, but it's going up, it's going down, and back up, and down, back up. So it's a bit more scattered. So visual description of it suggests, oops, that should say linear. Okay, linear. I'll come back to those values. Visual description of residual. I'm going to say scattered. And its equation was, so its R squared was 0.96. So for the moment, let's just stay with 0.96. Let's ignore, oops, wrong spot again. We won't worry about the R for the moment. 0.96. And my equation is, in this case, 1.34. Y equals 1. So it's log y, I should write it as not y equals, because you've got to be careful with that. It's going to be log y equals, and I'm going to go 1.34, 1.34, and then I'm going to say minus 0.03, minus 0.03 x. All right, so then we go x versus log y. We're going to go here, so that was reciprocal y. Okay. Again, what you're looking at here is residual. It's going to be scattered. And from looking at that, that's linear. Okay. This was, I think, 0.944, 0.94, 0.94. Going to go scattered. Okay. And so this case, it's going to be 1 divided by y equals negative 0.06, negative 0.06 plus 0.016 plus 0.16 x. Now I look at log x versus y. So in this case, I change that back to y. I change this to, was it log x, I think? Log x. Change this to log x. And we can see from here that we actually do have a pattern. Okay, so I'm going to put pattern here. I'm going to put non-linear. Oops. Non-linear. I've got an r squared of 0.96. And my equation would be y equals 29.9, y equals 29.95, 29.95 minus 19.04 minus 19.04, and it was log x. So times log x. Okay. And our last one here is going to be, I'm going to change that to reciprocal x. And we see that in this case we've got it's linear again. We've got enough scatter going here. It's looking sort of like pattern, but there's enough scatter there that you could say there's no pattern. Okay, so I'm going to say linear, pattern, no pattern, scattered, sorry. Scattered, oops, 0.98. And so it's going to be y equals negative 0.44, negative 0.44, plus 94.58, plus 94.58 over x, because I can write that as, because it's 1 over x. Okay, so let's have a look. I'm going to cross out using red, the one that's nonlinear. Okay, that was supposed to be red, clearly not. And I'm going to pick the highest of it. So that means I've got this one, this one, and this one left because they're linear. And this has got the highest r squared value. So that's the best transformation. So if I wrote in terms of y and that, it's going to be, oops, y equals negative 0.44 plus 94.58 over x. And when we write that in terms of its Variables, what remember, y was student jumpers equals negative 0.44 plus 94.58 divided by the temperature. Okay, and that would be, this is the equation that you need to make sure you have when it asks for it in terms of the variables. And what you might need to do at this point here, actual number of students, this is sort of, you actually calculate a residual. Okay, so in this case, I go 25 degrees, I look at the actual number for 25 was, number of students wearing was 3. So I put here, 3. Predicted number, that's where you'd use, you'd put, okay, and that's, so what you then put is, you'd put your, put in here, you'd go y equal, so y equals 0.44, that's a negative, I'll write that again, negative 0.44 plus 94.58 divided by 25, and because I'm running out of room, that's going to equal 3.346 or something like that, something close enough to that. Okay, I might be slightly wrong on that one, but it's going to be around that number. Then the residual, all it asks you to do is go actual data value, 3, so residual would be 3 minus 3.346 equals negative 0.346. And that is what the activity involves, this sort of activity involves, okay? And that is done. Thank you.